And we are back here live from the AWS Sydney Summit. Welcome to those who are just joined, and thank you for continuing to view us for those who have remained. We actually have an exciting panel in this session. We've got an all Amazon panel. So of course, I'm Dean Samuels, Head of Solutions Architecture for Amazon Web Services Hong Kong and Taiwan. And then down the end there we have...
I'm Kurosh. I'm a solution architect based in Sydney, focusing on machine learning and data science.
And by this stage today, you may be sick of me. I'm Shane Baldacchino, solution architect.
We can never get too sick of Shane.
Thanks, Dean. Thank you, mate.
But of course, this is the man of the hour that we're going to be talking to. He was actually introduced to me as the super awesome machine learning expert from Amazon.
Oh, you missed the brilliant.
Brilliant as well.
Yeah.
But I'd want to see your business card because that's a long title.
I use small font.
Right, small font, right. But I'll let him introduce himself.
Yeah, so I'm a senior machine learning scientist on the Amazon.com side. That was quite an introduction that I probably can't live up to, but I'll at least try.
Right, I think you're being humble too.
I mean, at first, I tried to be an interpretive dancer, and then I decided, maybe that wasn't right for me, so I ended up in machine learning.
Well, feel free to explain some machine learning concepts in interpretive dance. We'd love to see that.
I mean, I think that would be an interesting challenge.
And also, it is important to know that Mike is from one of our great customers, Amazon.com.
Mm-hmm. Right.
And also the sister company.
Yeah. So if you have any questions for Michael just regarding machine learning in general, if you want to see him do some of that interpretive dance, make sure you ask those questions and our moderators will see what we can do.
All right.
But of course, we want to talk a little bit about machine learning, Michael, and you mentioned there that you're a scientist. Mm-hmm. So when I think about scientists, and by the way, my brain shrunk when you started saying scientists, but when you talk about scientists, you talk about PhDs. When you talk about machine learning, it sometimes scares people off because they think about these deep learning, machine learning skills that they need to know about. They need to know about frameworks and algorithms and models and training and deploying.
And lots of math.
Plus all the math, right? And those type of folks are very much in short supply. If and when I ever have kids, I'll definitely be telling them to go into this field. But do you need a PhD to be a machine learning expert or even use machine learning?
Yeah, well, if you did, I probably wouldn't be standing here because I don't have a PhD, and that's kind of one of the...
Love it.
That's kind of one of the things that I really like talking to, is it's not really about the specific mathematical details, all these crazy equations that you see on paper. There's actually a lot more logical, more development ideas in how we make machine learning work in real customer use cases. So I mean, I think I definitely get it when people think, this is something really scary, it's intimidating. There are a lot of components, but I think developers really have a lot of the building blocks to become machine learning scientists.
Right. Yeah, and that's one of the reasons why our mission at AWS is to really put machine learning or artificial intelligence into the hands of the everyday builder or developer. Mm-hmm. And if you have a look, I won't spend too much time on it, but if you have a look at the AI machine learning stack that we have, it really caters for that wide variety of type of professionals you spoke about, whether you're those hardcore data scientists that really understand those frameworks and algorithms, so services around that, all the way up through to those managed services that you can actually access through various APIs, right?
Mm-hmm. That's where I'm at. And we make it really easy. I think, getting started in ML. What's your take on, say, Deep Racer League here? Have you had a look at it?
Oh yeah, I was up there earlier today. I'll see if I can put something in there,
Actually, right?
I'm sure you can.
We're currently 14 seconds, I believe, is the going time here.
Okay.
We're expecting big things here.
That sounds pretty good. I saw the track. I don't know if I can beat that, but we'll see.
So, Mike, about the approach, the difference, and potentially the overlap between machine learning and development, software development. In machine learning, a friend of mine, much wiser than myself, compared it to murder investigation. Where
are we going here?
Exactly. So with machine learning, you come up with a hypothesis.
So you're saying machine learning is murder?
Kind of.
Okay.
So you come up with a hypothesis and you work backwards from that into basically collecting evidence and then either confirming or refuting your hypothesis, correct? Mm-hmm. In software development and in general, in engineering, we're talking about the very well-defined input, very well-defined process, very well-defined expected outcome, right? what is this overlap between them? How can the developers in our audience can take on machine learning, and what sort of switches they need to turn on in their head?
Yeah, so maybe I can start with an example that a lot of developers talk about is kind of test-driven development. And the idea behind that, I think, is essentially you're prototyping something, you're building something, you know there's going to be bugs in it, you know there may be problems in it, and you want to know, when is this going to be ready to put in a real service? When is this going to be ready to be deployed? That idea of test-driven development is actually very similar to what we do in machine learning. In fact, our tests are, instead of tests being sets of code, it's sets of data sets that we say, we want our models to be able to predict well on a certain type of data set. I think that's a good way of thinking, like, how do I get this model in production is the similar answer to how do I get this piece of software in production. You want it to do well on examples that you're going to see in the real world.
Makes sense.
So Krosh mentioned about working backwards as well. So can you maybe talk about, we use that term all the time at Amazon, we always want to work backwards. We want to work backwards from the customer. But sometimes that could be misunderstood that we're going backwards rather than going forwards in terms of innovation and iteration. So what do we mean by working backwards and mixing that with machine learning and predictive development?
Yeah, so with working backwards, the way we define our models is usually from the outputs back to the inputs. We're saying, if we're trying to develop recommendations, for example, on Amazon, and we want customers to find more relevance, they want to find things that work well with the other products they're seeing, we work backwards from that goal and then develop the model that can try out hypotheses, adjust its parameters. If it doesn't perform well on those evaluation metrics, we'll either try a new modeling technique, or hopefully what we're trying to do is get to models that learn from that data. They say, we're predicting well in this one area or this one category, but not in another. How can you use those data sets to help inform your model to get better on that?
Right.
So that's kind of how we see working backwards from the machine learning flavor.
So Mike, this working backwards, how much and what percentage of your time do you spend in defining the problem, and how much is going to be on modeling and reiteration?
Well, after the interpretive dance, that usually takes about 80% of the time.
Exactly, that's what I thought.
No, I think it really is the majority of the time is spent on developing really nice gold standard data sets, understanding what your goal is with the models that you're building. Because at this point, I think, 10 years ago, we didn't have AWS, all these tools that make it so easy to, once you have that goal that you're working backwards from, have all these tools and these services that basically you're just putting together. You're not starting from the ground up.
Exactly.
So the interesting part about machine learning is you're spending that time on the stuff that's interesting and that's really customer facing.
That matters, and as we call it in AWS, the undifferentiated heavy lifting. We take that away from you.
Hey,
go ahead.
Say, look, there's a question from the Twitch feed here. So Skull Crusher for Life asks, is there any data that you often find wasn't collected by a company that would have helped find a correlation between records that aren't specifically domain specific?
Is there any data you found? I think one thing this question might be leading towards is a concept of transfer learning. And the question is, do you need data in exactly what your target output is? Do you need data in exactly that domain? And I think one of our approaches to that is trying to use transfer learning, or use machine learning that can look at data that maybe doesn't have as many labels on it. It doesn't have as many right answers basically baked into. Maybe people specifically annotated, this is a relevant product, or this is exactly what I wanted. You look in slightly different areas and you say, maybe I can learn from other text data that maybe isn't product, for example, in the Amazon domain, maybe isn't product specific data, but it's stuff that can help us understand the text that is in product descriptions. So I think that's one of the ways to bring in kind of data that's coming from a different domain.
And I, yeah,
So-
go ahead,
and
please.
we've actually got a few services from AWS that help with building and training these models. I want to set a challenge out to the viewers. We'll give away some AWS credits to the first 2 people who can actually answer or provide at least 5 AWS AI or machine learning services, whether it's those that operate at the top stack or top layer for managed APIs, or even down at the lower stack for our data scientists and machine learning specialists. And so you've used a few terms there in terms of machine learning, learning and reinforcement learning. Can you maybe tell us the difference between things like reinforcement learning is a big, I guess not so much a buzzword, it's real, but can you talk what do we mean by reinforcement learning?
Yeah, so before we start on reinforcement learning, I always like to start with learning. Like,
Sure. Okay.
Sounds obvious.
If I'm on a new project that I'm not an expert on, what process do I take to become better at that? And I'm probably going to come up with some reward function of what I'm looking for. I might say, I want to understand the breadth of this topic. I want to be able to understand different components of it. Or I might want to go really deep and optimize on the number of, I really want to get good at the vocabulary of it. So I might say, I want to learn as many terminology in that. Those things you can define as a reward function. It's something you're trying to optimize. What reinforcement learning is doing is saying, once you create that reward function, let the model try and figure out how to take actions towards optimizing that reward function.
Right. Does that mean then you don't have to worry about a vast amount of data for doing the actual training, because you're relying on this reward penalty type approach with reinforcement learning? Yeah, so it's kind of like when you're a kid and the way you learn is you either get disciplined for something you do bad or you get rewarded for something you do good.
Yeah, I mean, reinforcement learning actually came from earlier like neuroscience work, and it's like, yeah, if you get penalized for something, you're going to do it less.
Right.
If you
Get rewarded, you're going to do it more.
Yeah.
So is this how Deep Racer is working?
Yeah, so I think with Deep Racer, you're looking a lot at the reward functions, and I think people
Correct.
are creating different reward functions. And the cool thing about that is, I think when you look at those rewards, it's something more intuitive to people. You don't need to know what backpropagation is happening through the model. You can say, I kind of want this, racer to really hug the edges of that lane.
Or
I want
probably
to
slow down when you're detecting a curve.
So that kind of goal-driven, reward-driven development makes it easier for people to bring in new ideas into that domain. You don't have to be a mathematical expert to say, I want it to go fast on straightaways or something like that.
And you might have alluded to before, Mike, about that working backwards approach. But what would be one or two of the core ideas to focus on first, and when you are starting out learning?
Yeah, so I think one of the big things that I really want to emphasize is there will be times where you maybe need to pick up some mathematical work, but it's going to be so much easier if you take the view of this is about learning. It's not this crazy. It's not. Machine learning isn't something totally new. It's not something that developers have never seen before. There may be new terminology, but having that understanding of, for example, when we look at you may hear terms like backpropagation. What it's really doing is, how do I adjust my model in a way that does better on outputs? It's something that's a lot easier to pick up those mathematical tools once you have a little bit more intuition. So I say, don't quite jump into that really deep science. There's so many tools out there that can help you gain that experience through actually building stuff.
Right.
So Mike, in 30 seconds, the key takeaways that you want your audience to know.
Okay, let's see. One, I don't think you need a PhD to do great machine learning work.
That is definitely a relief for me.
Excellent.
Because I have a few units to get my PhD, about 12 years worth of it.
Okay. Might be a little cheaper too, to not have to go through
We've
that.
actually fortunately got a little bit more time because there's been some special requests by the viewers to get more information from you.
Okay, all right.
Nice.
So the previous session, we actually asked the guest host about his preference around some programming frameworks. So when we look at some deep learning frameworks, are you a TensorFlow guy? Are you a Cafe guy? Are you a PyTorch guy? What kind of guy are you?
Yeah, what's your favorite?
You're entering the religion. That's religious questions.
The most appropriate answer is like really picking the right tool for the right job.
Yeah, I mean, let's use the working backwards approach and say, you know,
whatever's best. For
whatever's
the use case,
best.
right?
I think underlying all those tools, you
Unless
find.
it's TensorFlow, we use it for everything.
I mean,
we had that discussion before. Horses for courses, yeah.
Yeah, I think there are different benefits with the different ones. If you're gonna, my hesitation would be saying I'm going to definitely use this one framework. Once you know one of the frameworks, I think you can transfer some of those ideas to the other one. So I personally don't really have a favorite one.
Cool.
So is it true that they say machine learning and data science is written in Python and R, and AI is usually written in HTML and PowerPoint?
That's. I mean, I would say Python is definitely the key area that a lot of machine learning people, both on the engineering and science side, tend to go to, because it's nice to prototype new ideas. You don't have to go through all those optimizations, and yet Python, you can compile it down to lower level languages that can do that optimization, which is a big component of machine learning. What did you said about PowerPoint?
AI is written in PowerPoint and HTML.
I don't know. I mean, AI is written in a lot of things.
Hey, so look, I believe we have some winners, Dean, to
Oh,
these
we do.
to these questions
announce
here.
them?
Yeah. So look, congrats to what have we got? Two more. And XORD1S, congratulations on the
I think you should
AWS
get some credits for getting that name right.
I just couldn't even. I think my eyes are going here.
They optimize their rewards reward function.
Well, congratulations to those two winners of the AWS credits. Make sure you do pay attention to these sessions. We'll be giving our prizes throughout the day. Of course, we've got our CQ quiz session coming up as well, where you'll be able to win some credits. Before we go, just want to give a shout out to the REMARS conference that we're actually running in June. I'll actually let Kourosh talk a little bit about it, because I believe you're attending REMARS. Maybe just very quickly in 10 seconds or less, what is REMARS and what are you presenting?
Yeah, REMARS is a conference which is a replay of Mars, where actually Mike presented in. It's all about robotics, automation, machine learning, AI, and space. So I'm delivering a talk with my co-presenter on enabling sustainable human life on outer space, basically on Mars, using AI and machine learning.
Well, make sure you do check that out. It's a great way to get some learning experience, as well as a wide variety of various content that is out there. But Mike, really want to thank you for joining us today. Great to get some insights on the machine learning and artificial intelligence, and that I don't have to go back to university to become a
Excellent.
Awesome.
Sounds good.
Thanks, Shane. Thanks,
Mike.
Kourosh.
Thanks for having me.
Thank you.